All right. This is going to be a talk that I hope people will find of value, but if at some point you're like, boy, that's like a lot of information going by fast, just know I'm also doing this knowing that there's going to be a recording of this later. So if all you heard was like, there was that weird thing they were talking about leader that had a leader election, just know that you'll be able to pick this up after the fact, and I'll get the slides and everything up. So I'm going to make some assumptions in this talk. One is that you already kind of have an idea what Habitat is. I'm going to further make the assumption you were in Jamie's talk just immediately prior. And that doesn't necessarily have to be true, but YouTube recording, watch Jamie's video first, and I'll wait, and then come back and then watch my talk. So that's how it's going to work. So I'm going to do what is Habitat. So it's a runtime system for your apps or other services. It gives a way to inject real-time config to services. It is a reactive system that can react to other services and configuration to kind of do the right thing for the behavior. It packages software with a deterministic build system. There's a distributed build service to help rebuild those packages, and it loves your apps and services, and that's Habitat. I hope that's a record for the quickest and least explanation version of Habitat. So the alert here is that is kind of going to be, we'll level set that some of that might have made some sense. So I think this was from Jurassic Park, right? Like I know this, I know Unix. So we're just going to assume that I kind of know Habitat, and there's like the supervisor and everything in the gossip ring. So it's all right if you're still kind of, if all this is sinking in. You could just think of it as if Jamie had 40 more minutes and we keep talking. That's kind of what I'm going to do here. So having said that, if I am in danger of going too long, or there's too many questions, or if it's easier for you to sort of see it working on a laptop, please come to the Habitat zone. That's when you went to the registration desk. It's just behind that, down the hall, and on the right. It's just a little corner tucked away. I've been told there's beer, so I'm really banking on that, because that's where I'm going to go immediately after this, and I will just stay as long as I need to answer questions. And we've got that basically staffed for the whole time, with including some scheduled like talks and demos. So what I'm going to cover here are kind of things you need to think about, or things that if you know about them, you kind of know what the Habitat building blocks are when you're composing architectures and things at runtime. So I'll talk about our service topologies, the service bindings, our update strategies, release channels, some of the keys and cryptography stuff, service configuration, and that's it. So for topologies, when we're talking about topologies, what we're talking about are if I had an app and it's all the same package that I'm booting, so maybe it's a Rails app, and if I'm booting it in the same service group, kind of by definition, that they all kind of cluster and self-form and will work together to do what they need to do. So there are some kinds of apps that if your app is stateless, or if it's sort of the share nothing architecture where each of those cluster members can work independently, then actually our topology strategy is not a ton of use for you, which is great, because like you've probably already got a good app at that point. So there is a topology. This is when you start the service, you give the service a topology that the supervisor then knows how to run. So the standalone is our kind of implicit default topology. So if you've ever kind of done a hab start or saw something going, just know that you're running in a standalone topology. So if you booted other ones, and if their supervisors knew about each other and form a ring, you have a standalone topology. If you need a little bit more than that, and this immediately becomes useful when state starts to matter, or when you have an app that's that kind of app where one needs to be different from the rest. So if it's a database, maybe you need one to take the writes, and the other one could take the reads. Or you maybe have a little service that's basically a while loop doing a periodic task, and that's cool. And you might want a few of them running just to make sure that the task happens, but you only ever want one of them running at any one time. This is where like that leader topology can be handy. And all you're really doing is adding this dash dash topology flag with leader, and then all the services that are running, again, with the same name of the package and service group within the ring, they're kind of form and have this leader topology. So it's a little dark in here. We'll see how this goes. What I'm going to do here is just boot 3 supervisors, and to keep things simple, each supervisor is only going to manage 1 service. So when we boot the first time, and I'm going to put all these in the leader topology. So what the supervisor is going to do is make sure I have the software for that package around. Then it's going to go and check to see, do I have other members in my service group already? Because if we want to have a leader for this group, we need enough kind of voting members. So some like minimum quorum. And right now in our implementation, that's just 3, because you can at least break ties and that kind of thing. So what the supervisor is going to do is in the services state machine, it will get it to the point of knowing that, oh, I need other voting members in the service group. So the supervisor is basically going to be there in this waiting state, and you'll see a message saying like waiting for quorum or something like that. And what that means is when you boot the second one up, it will come up and these 2 will be discovering each other and realizing, okay, now we have 2. We have 2 out of 3. We still can't continue though. And it's only until like the 3rd one comes in that now there's enough members that can actually hold an election. So during all of this time booting, the service that was underneath it, let's say it was Redis, at this point, no Redis process has been started. So the supervisor is like waiting to make progress so that service that boots has like all that it needs to be successful. And if the intention was that you have maybe a leader that takes the right and the followers that are just doing read-only replication, you don't necessarily want to have to boot those things if they're just going to be restarted or in a really weird state. So that's kind of why we're doing that, and this kind of layers in with bindings, which I'll talk about in a little bit. But at this point, the supervisors can have take a leader election, and the details now are a little bit more important, because I used to be able to just say that the leaders will have an election and then there'll be a leader. What's really happening is that the supervisor itself, on behalf of the service group, they're going to have a leader election for those members of that service group, so all those little Redis instances, and then we'll get a leader. And you could kind of think of it as like this supervisor sort of had the crown of the leader, and we're just going to bestow it on that service, so that service member is the leader. Which means if you're running 2 or 3 different services on each of these supervisors, there might be a leader on different like physical nodes or supervisors for each of them. That's the idea. So the other thing that is also kind of plays into this, and that helps when you're kind of like booting all these things up together, is this notion of service bindings, or the bind flag, which Jamie talked on in the talk previous. So there are technically 2 kinds of bindings. It's the one that normally you're setting up in your package, and it's said the word bind. That is now like I would call it a required binding. All that means is, so for this example, I just have just a fictional like Rails application. So I'll try it out loud. So it's supposed to be an abacus company, so like those crazy calculator things. And in the Habitat team, we kind of like puns or tongue twisters. So we've got an origin or a company that I called Abahab for the abacus and Habitat. And its web app that does all of the abacus online stuff is going to be Webacus. So Abahab Webacus, I did it. And we'll just assume that I use our new Ruby scaffolding that Jamie showed. So one of the things that'll do for like a default Rails app, if you happen to have the PG gem, is it's going to detect that and know you probably got a database going on. Your Rails app's probably not going to boot without a database. And I also know it's a Postgres database. So what it does when the package gets made is it makes now it's a required binding. It was originally a required binding. which meant if you started this out and you omitted that dash dash bind, the supervisor would tell you, you have a required binding, like you need to fulfill it. And you could think of the part before the colon, so the database word, is kind of it's a label or a role, or it's the requirement, it's the need of myself as that Rails app. It's the thing that I need. I need database, and something will provide me database. And the way that we fulfill that is by telling this line that the part after the colon is another service group. So that's basically like, it's this database cluster that is going to be that's going to fulfill your need of database. And what that's going to mean is this will work whether or not that particular service group exists in the ring, which means if you haven't booted your Postgres database cluster yet, as far as the Rails app's concerned, there is no Rails app, so it's totally fine. What the supervisor is doing, again, is going out to see, okay, where's the Postgres QL.default service group? There is none yet. So I'm going to wait until I actually see it. And you'll see now in the supervisor output that I don't remember what the message is, but it's basically like I'm waiting for this service group to exist. Because at that point, we can, again, make forward progress towards that app being in a good place. And it's a combination of this and the topologies that that mean we're getting closer to a world where if everything was in Habitat packages, if that's what you had, with services that can start up and they can all communicate with the ring. For my Rails web stack with maybe Redis and Elasticsearch, I can literally just boot all of these at the same time with the supervisor, but they won't start their actual processes until their needs are met. So until their needs are met, then they will start, and then they can turn around and fulfill the needs of whoever is depending on them. So for me, this is like beautiful Mark Burgess promise theory that I know just enough of because I read most of this book in a resort with a lot of rum, and it was really clicking when I was working on this stuff. So it kind of makes these things of like being able to boot everything and have dependent service order loading actually work, which is something I was trying to do for a long time in Chef. It's the thing that I kind of wanted, but I couldn't articulate what I wanted. So the optional bind, it's another way when you make a package, you can say that instead of a required bind, it's an optional bind. So what happens is if you add it on the command line, just like before, it's treated as though it was a required bind. So again, it'll wait if it needs to and then make forward progress. But if you omit it, it's not going to fail or anything. So this is currently the way our Ruby scaffolding is actually using the optional bind, which means you can point it at a Postgres database that's in Habitat, or if you leave the bind off, it's going to, it's in our init hook. So before the Rails app boots, it's going to keep dying with an error message saying, you need to also add a host and port like config. And if I have those bits of information with what you already had to provide, that means you could point it at like an existing or a new like RDS instance, or if you want to say you're on an app team and you want to try out this Habitat thing, but you already have an acceptance like database, you can just point at that database and see that like, yep, same Rails code base in a Habitat package, works the same, point at the same database. So I think there'll probably be more use for these optional binds now that we sort of have the behavior the way, I'll say the way we want. This is the way I wanted it, and I like it. And yeah, so it works either way. This is just a bit of a visual for the bindings. I was talking to Jamie. I think he's affected my brain that like I kind of think of it a little bit as a power socket as well. That is, as long as like the contract of like your type A or F or whatever match, you can like draw that requirement down the wire to your device. So so I guess this would be in the middle, like our Ruby app or our Rails app, and it looks like we have two binding dependencies on Postgres and Redis. So Another way you could think about bindings is in our build system at build time, you might have build dependencies, so software you need to build something. At runtime, you might need software also installed alongside it, like libraries. This is kind of like your runtime dependencies. So like, these are the things that when I boot, I'm gonna go talk to and like, that's kind of where bindings come in. When you're like mapping out the architecture on a whiteboard as well, it's probably the lines between like your app tier and your database tier. That's probably like in the Habitat world, that's probably service binding. So our update strategies is going to be dependent on your environment and your use case and your worldview and your company. So we have everybody, I think, on the team says we have 2 update strategies, and that's wrong. We have 3 because there's one that's none, and that to me counts. That's the default. So you can say strategy none, and you'll be fine. All this means is when the Habitat Supervisor is going to run like boot your package and start your service, it's just not going to update it. So it's just going to keep running it. And that's pretty good default behavior. If you're bought into like the immutable infrastructure or like versioning images and that kind of thing, you have no more extra work to do. Those bits that were laid down, you're going to get no more bits, at least as far as Habitat packages, and you can kind of just move on. However, yeah, and that's the default. However, if you're in an environment where you might be on virtual machines or bare metal hosts or even in containers, and we kind of think of the immutability in terms of Habitat software a little differently. Like the packages themselves are immutable and atomic, just not in the container sense that like there's more bits on disk. So you could just think of it, we're just thinking about immutability differently. So I would still argue that what we're doing could be still considered immutable. But the at-once strategy is basically the simple version that when it starts, what the supervisor is going to do is just check to make sure the version I have installed, is that in fact the latest one? So it'll make a call to the depot and check. And if it's good, then it just keeps going. And once it's running, it basically just has a timeout loop that keeps pinging the depot to say like, is there a new version yet? I think it's something like 60-ish seconds. So within a minute or two, if there's a new version published, then it would pull it down to the update. But this is kind of like a Wild West. And again, if you share nothing and very stateless, this could be great. They're all just going to be independent actors, even though they might be in the same service group. And if you need a little bit more control, there's a lot of names to this pattern that if it's not the like all at once, it's like an incremental rollout or a one at a time, or what we realized on the Habitat team is a lot of those cases kind of boil down to the do one at a time is like the simplest version of all those other cases. And the other ones are like, do you do it percentage-wise? Is it incremental rollout? Do you do it exponentially? So those, I think, will probably be just behavior that we tack on to this idea of a rolling strategy. So our default behavior is for rolling right now is one at a time. So what we've got is 3 supervisors in a ring, so they're all talking to each other. We've got right now we've got this one crown. It maybe should be on the service, or we needed a different color crown. This is an update leader. So when all the members in that service group are in a rolling update strategy, they have sort of a different election for this update leader, and its job is just to keep pinging the depot to see if there's anything there. All the other members don't have to do that, which saves us on the Habitat team from having an awful lot of just like pings, and it saves your network, and it makes a whole lot more sense because we want to coordinate this anyways. And so if a nice new magical package shows up, whenever that timeout and check happens, that update leader is going to see that. And then what it's going to do is start this process of doing the update. But what it's going to do is have every other member do its update first and itself last. So it's the update leader that's going to tell everybody, like, this is the version that we're all going to, like, we have all agreed we're going to go to this version. And so this would be one of the non-update leader members, so one of the update followers, I guess, sure, would do its update. And then once it's done, it's kind of like a relay race where it's like I had the baton and now my job's done and I'll hand the baton off to like the next member, and then the next member would go, and then finally the update leader goes last, and then it just kind of continues going on. So if you have this, if this is kind of like more the class of the software or the service that you sort of need that more controlled rollout, or that involves maybe you can't deal with, with the at-once strategy, you might be taking outages on like those things coming up and down. It's hard to control. So this is at least a way that you've got more control over maybe how many health checks on a load balancer might be flapping and updating. So that's kind of why we started with the simplest case we could think of. These things are all kind of basically they're patterns for how to run applications and clusters. So we've tried to give it a reasonable name and have as few of them as possible and hope that we cover the vast majority of the cases. So there could be something out there that doesn't cover like the none, at once, or rolling with a little bit of behavior tweak or tunable. And if anybody knows about that, it would be great to have a chat, because we're always sort of making sure we're going to hit as many use cases as we possibly can. So next, I can touch quickly on release channels, but I think I might use a very similar slide to what Jamie showed before, and it's a little bit small on here. But so in my mind, what we did with our update strategy flows completely and logically into the need for channels. So the way I think about these two things is the way that like pretty much all modern web browsers work, like Firefox and Chrome. I think even Microsoft's Edge browser works. I would imagine most of the people in this room have at least one of those, and I'd imagine almost everybody has no idea what version that is. I have absolutely no idea. I don't even know how Chrome like versions their stuff anymore, because I don't think about it. All I know is I installed it, and by default I got like the safe updates. So I guess I'm on like the stable channel, and it updates itself. And sorry? Oh, sorry. I thought it was a question. But I know I can change my browser, and if there's like features that I want, I can like change that, and I can go on the unstable channel, and then I'll get new features, and it might break every once in a while. So, and based on that might be the frequency that my software is updating. So that's kind of the yin and yang that we've got with the update strategy, is like the update and the pull. The channels is the way to sort of control the push or the release of those packages. So what we have in our depot, and this is reasonably new with the launch of Builder, and a lot of work we had to do behind the scenes to kind of get this realized. This was something we knew we wanted, and we knew we wanted a few other things, so there was a lot of work in flight for this. So a channel, you can basically have a channel, it's like scoped to your origin. So like for myself as F. Nichol, like I have an origin, which means I already have some channels, and I could make other channels if I wanted. So everybody gets like a stable and an unstable, and those are names that that you can't change, you can't delete. So that allows us, in the user tooling and the experience and some of the logic to at least make some assumptions. So we can do stuff like maybe by default what you're downloading from is stable, and maybe what you're uploading to at some point may be unstable, so that if you need to test something in the package or pull it into another environment, you don't necessarily need to like effectively upload it live for your production. I mean, the fun fact is, up to this point, that's what we've been doing for our own service, because we haven't had channel support. So sometimes uploading software has been done with a little more thought and effort on our part, because if we do something kind of wrong, everyone else is just consuming our stuff. So everyone is effectively live testing what we've uploaded, which is really fun. But I'm really happy that we're going to have channels. That's going to help our workflow. And if anyone's a Chef Automate user, or if you've seen delivery, and that's just the old term for what's now Automate and workflow, and you've seen those environments where things go through, like the staging and union and stuff. You could kind of picture like a similar channel for each of those. And all we're doing when things are succeeding is we're promoting that package and then every other package that it depends on for like to run with, is we're promoting that from one channel to another. So from maybe from acceptance to production, or from dev to unstable, or whatever it is. And like really under the hood, it's the same heart file, it's the same one artifact. The channels is kind of like a materialized database view. So it's just a logical construct to select a bunch of them. So it means promotion and channels are relatively free speaking. Like we're not doubling our disk space by adding another channel. That would be scary. But the nicest thing is it's so much closer to what I understand that continuous delivery of a build artifact, like an actual artifact. And that's something I'm really happy about, is once you've built that thing, that is the same artifact that you're moving. And if it's bad, you build the next one, and that release candidate's kind of like not used anymore. So you're not like rebuilding packages as you go, you're just promoting them. So I'll talk a little bit about keys. This is kind of, I guess, a reasonable overview for like what we have for various keys. So there are a few in Habitat. What we've tried to do is to do the most right thing we can for ourselves and for users, and at the same time not having the user being completely overburdened with key management and all that kind of thing. But there's sometimes stuff that you just can't boil out, like you got to know something or have something a lot of times for these things. So we do have a few things going on here. So I'm just going to step through some of these just so you kind of have a sense of what's what. And these all end up mapping to like a have the thing key generate, most likely. So the origin key, if you've ever built a package before, you've probably seen a key or seen the tutorial. It's the thing that you generate that has your name or your company's name. And really under the cover, if you've seen an SSH key pair, it's basically like a public secret key pair that we're generating. And we're using that so that when your Habitat package is built, it's going to sign that package with your private key. And then your public key is going to go up to the depot. So anytime anybody, anywhere is going to install that package, that public key needs to be present on that host, because it's going to, the first thing it's going to do is verify like the signed checksum kind of thing. So that, you know, it's hard to know if I can even trust this heart or not. So that's kind of what we're trying to do, is to build that in and not have it be like the additional step that like, now that I figured out how to do packaging, now I can add this signing on to it. Like there's no way not to have that. So that's where like, that's how we're trying to do about as right by everybody as we can. And kind of as we go forward, this is where things become slightly more optional, and it is based on your use case, and this is where like the work becomes a little bit harder. So there's also this, oh, I'm sorry, this was an example of just generating an origin key, and then I'm just calling our hab package build, which is using the studio or studio instance to do a build. I'm just not entering it. And this is one of a few ways that you can say, I want to use this origin key in my studio to sign against. So the next key we have is a ring key. This is kind of it's kind of like the password, it's the secret password to get into a party. So this is a key that you would use on all your supervisors when they start. It's a symmetric key, so it's what they use to like encrypt basically their wire communication, and then on the other side they decrypt it. So like there's not a whole lot to it. And when we were talking about this, when this kind of came up, this is where we sort of had to articulate the name of what the ring was, because it was too hard to explain. I need to encrypt the traffic around the whatever. And so we came up with ring, and unfortunately, like Beyonce's song was in my brain, and it's never left. So whenever I generate a ring key, it's always Beyonce, because if you really like your ring, you put a ring key on it. I don't know. and really, so when you start the supervisor again, you're giving it this ring flag. And what that's really saying under the hood is it's going to look in its key cache on the supervisor host and look for that named Beyonce key and use that so that it's encrypting basically all the gossiping messages. And so the last line here is using our config apply at runtime to inject some configuration in. But again, because that's sort of like tapping into the gossip system and talking to the supervisors, you need the same like cool secret password to get into the party of the Habitat ring. Otherwise, you don't get to inject. So that's what we've got for that. Service. I'm going to go over these a little bit quicker because these were features that this is more there than not. The user key is actually a bit more like future forward facing, but the idea is they kind of go together. So the idea with a service key is it's another public-private key pair, and it goes on like the supervisor for the services running, and it's targeting a service group, and that's going to allow us in the future to use another key pair, which we call a user key pair. So like me as an operator or as like a CI service or some trusted thing, I can encrypt some configuration and target a specific service group and do the signing with the secret in the public, and then decrypt the other way around. Anyways, the Diffie-Hellman key exchange kind of fun stuff. So the service key is like the service side, and then the user key is on the user side. Now, we actually had the command for this, and I had to start looking at code because like I didn't remember using this in a long time, and I was starting to wonder like, is this even wired up? And it turns out it's not wired up yet because the user's public key is something we're going to want the depot to fetch so that the supervisor can fetch that user's public key when it needs to do the decryption. So this is kind of like part of that when we launched Habitat and still doing work. We're still in discovery mode and still figuring out what are things that are important to people, what features are worth implementing, which ones aren't. So this has just been one that it hasn't come up really. So we haven't really looked at it again. And all that takes is somebody to be expressing interest or want to work on it or has an interesting problem where they work, and if they want to have some of the Habitat team come and sit in their house and we can bang this feature out. That's kind of how we've been doing this, is really with the community and kind of learning together. So I think I'm going to be a little short on time. So I will try to quickly cover this service configuration. So when I have a package, I've got some defaults that Jamie showed for like changing the port and that kind of thing. And I believe he used a config apply. So that's one way to like override the defaults for a service group. We've basically got 3 ways, and I would say this is kind of from least preferential to most, but that's also a little opinionated. So one way is in the 12-factor style from the environment. You can have an environment variable, and the pattern is it's just hab underscore and the name of the package. So mine was Webicus, so it's hab Webicus. The contents is toml. That's kind of the hard part. Toml's not great to like inline as a one line, but you can do it. And what you're doing is you're giving it to the supervisor when it starts, because it's the supervisor's process that needs that environment stuff. And so I'm just making that distinction that if you happen to want to use this on a host running, and you're like, I'm going to add this other service and I'm going to inject via environment, like that supervisor process is already running, and you can't. It's kind of hard to like mutate the environment of a running process. However, this works perfectly in a container situation where what you're starting in that container, that scheduled workload, is the supervisor. So like doing the Docker-E environment injection, that's kind of why this exists, is for that kind of use case. And that's probably, if that works for you, then that's probably the one you'd roll with. The one that I believe we might not even have fully documented, which we will if we don't, this question's come up, is you can also write a file or drop a file in a known location that also will work to override defaults. So it always goes in the same place. So with Habitat, most of the paths to where things are always in a known absolute path, and that's for many, many reasons, but also so that you don't have to guess. So it goes in this like /hab/svc, which is the service directory. It's a directory that all the running services, if they need state or anything, there's a bucket for that, and then just the package name. So in this hab/svc webicus, I can put a user.toml, and for the life of me, I can't remember why we chose the word user. That probably wasn't the best. But again, same thing, toml file. When the supervisor starts up, it will, if it sees that there in that canonical location, it'll pull it in and merge the config down. There's one caveat right now. This file, if it gets updated while the supervisor is running, we're actually not picking that up and updating it. That's just frankly just an oversight, and we didn't have the easy like FS watch functionality for a long time. We did for a bit, and then we got rid of it. Our multi-service stuff uses some FS watching, so the plumbing's all there. Just nobody's gotten to actually adding that. So if somebody feels rusty and are looking for a contribution, this could be a great one. The idea for this one is this plays really nice with configuration management like Chef and that kind of thing, that if you write the file, that kind of describes what you need, and that means logically you'd probably want to update it. So that's why I put the caveat that Chef could totally manage a file like this, but it might not update when you expect it to. The one that absolutely will and will always work, and is pretty nice, is our config apply. So this is using the ring to gossip the configuration itself, which lets us do some really interesting things. So for those last two, like with the environment variable, I needed to like directly start a supervisor with that service, or at least at some point it would start a service, but I need the supervisor running. With the file one, I need a host with that directory already existing so that it'll eventually go. This one, you can target a service group that doesn't yet exist. And what's going to happen is the supervisors are going to keep that around, knowing that if somebody comes up in that service group, they're going to get that as their state of the world and go, oh, I got something that applies to me, and they'll apply it to themselves. So this allows for really awesome behavior, like having a few of these configurations for your various service groups, having at least one supervisor running, just apply them all, and they're in the ring. And then as you boot the services, they basically, like when they boot, they get their config, so it's kind of like preceding, which means, again, the timing problem of what is the order that I do everything. This gets me close to the world I want, which is like, if I get one thing, I give it some config stuff, and then I tell all of them to boot up. With all this stuff before, this is kind of like the magical system that I've been wanting to have forever, and like we're getting close. I'm just showing a couple ways. It takes a toml file as an argument, but also accepts standard in, because that's a good Unix thing to do. So I will often just echo my one thing and pipe it right into config apply. And the one thing that Jamie did mention, and he uses the same term I do, a monotonically increasing integer for our incarnation. That's just a way, if there ends up being different versions of config, we need to pick a winner. And so we just use an integer for that. And what I've started to do is just actually use the date, the Unix date command. All that does is that just gives me the number of seconds since the Unix epoch. And whatever our integer type easily handles this. So this is going to be fine for like a good long time. As long as you have like few things, like if there's like a CI worker that might be doing this, and then bumping that, as long as you're not doing that for one service group more than once a second, you're going to be fine. And if you are, I'm a little confused what's going on. So, and I might save this for the Habitat zone. It's kind of the idea of taking those files that you could use config apply and put it in a Git repo with like on a merge to master, is see like which toml files have changed, and based on the name I can get the service group, and I will just do a hab config apply. So it kind of lets us have versioned config for a ring, because it's really nice when everything's in code, including configuration. So I'm just going to go through that, and we did it. I heard an alarm, so we made it. I'm going to be heading upstairs to the 4th floor to the Habitat zone for anything remaining, and thank you very much.